All right, this is the first of a handful of videos that we're going to have on some of the kind of starter, basic related rates problems. So this one, we have a circle. All of these have a picture to go along with them. It's always nice to have that. You drop a rock in a lake causing circular ripples. The radius of the ripples is increasing, so they're going out at a rate of 5 inches per second. We want to know how fast is the area of the circle increasing when the radius is 10. So with these related rates problems, we want to identify what we have. We know R is equal to 10, and we want to know dA dt is what? We also know that R is changing. And we know that dr over dt is equal to 5. And we can write inches per second if we want. All right, so those are our givens. And we need to, we need to find this right here. So the first thing I'm going to go after is what two variables are we working with. In this one, we're working with R and we're working with A. So for a circle, I need to figure out an equation that relates the radius and the area. You should know that one. That is area equals pi r squared. From here, we're going to d over dt. And actually, before I do that, you may say, wait, I thought the radius was 10. Why don't we plug that in? We need to derive the equation that relates the two before plugging anything in. So we get we do our derivative here. The left side is just the derivative of A with respect to time. The right side is going to be pi times power rule, which is 2r, times the derivative of the r with respect to time. So dr dt. And that's implicit differentiation, and we've talked about that quite a bit, so I'm not going to go too long into that. But from here, I'm just going to simplify and then plug in my values. So I've got dA over dt equals 2 pi r times dr over dt. Now, what do we know? We know that dr dt is 5 inches per second, and we know that r is 10, and we're looking for this. So I can slide all those things in. This is going to go in right there. This is going to go in right there. So from there, I'm going to go ahead and get dA over dt equals 2 pi. I'm going to write times 10 inches because I want you to see how the units work out. Times my dr dt is 5 inches per second. That, if we ignore the units for now and just multiply everything else, I've got 5 times 10, which is 50, times 2, which is 100, times a pi. So I wind up getting 100 pi. And then what are my units? Well, there's two ways to figure out the units. The first way is to say, hey, undo point. We're working with dA over dt. So what are the units of area? Well, that would be inches squared. What are the units of time? That would be seconds. So it would be over here, inches squared per second. The other way to see it is that our units should actually always work out. Here I've got inches times inches per second. What do I get when I multiply inches by inches per second? I get inches squared per second. And that is the answer to this one.